let me leave this one up here for just a second. That's x plus 2y equals 0. And refer back to a couple others. I know we had, what, x plus 2y equals 8, looking like this. What was another one? 3x minus 2y equals 12. Let me see if I can squeeze it in right here. Yeah, that'd be good. All right. What was it? 4 and negative 6. Yeah, these were just some we did earlier in that other lecture. Okay, other part. Well, the reason I put these back up here is to talk about something else. As we can see, lines tend to have different slants. If we go from left to right, we can see these are going downhill. These, the one on the right and the one on the left. The one in the middle, though, is going uphill, talking about left to right. They have different slants. Lines have different slants. Actually, the one here on the right and on the left actually have the same slant, but different placements there. But that's what I wanted to talk about next is talk about the slants of lines and the measurement of those slants. The measurement of the slant of a line is called its slope. And actually, steepness is involved there too. Because if I have another one, let me just give a more extreme example here to compare here. Yeah, if I have a line slanted that way, well, it's going uphill, but it's much more steep. Slope tells you about that particular, those two particular things. How it's slanted, whether it's downhill or uphill, and how steep it is. This slope is going to tell us also about steepness. Okay. Well, here's a couple of definitions, I guess, if you will, in addition to that one. One way slope is known by is what's known as rise over the run. The slope of a line is a ratio of these two quantities. It's how much the line rises from one point to another divided by how much it runs in that for those 2 points as well. The run is the change horizontally speaking. So it's the change in the vertical divided by the change in the horizontal. That's what we're talking about there. Okay, well, if you look at it, let's say hypothetically here, we're going from one point to another point. So the rise is how much rise you have here. Let's say that's 2 to 6. So it rises 4. Got a rise of 4. Then the run is this measurement. So let's say it goes from here to here, which is 2 units. The rise over run there is 4 to 2. 4 rise to run 2. That's what one way you can think of the slope. How much it rises to how much it runs from one point to another point on that line. Now, of course, as you can see there, it is a fraction, so you would reduce that. That would just be 2, a slope of 2. But that's one way you can think of the slope, and we'll talk more about that later time, next time, more than likely. Okay. Now, let's focus on this a little bit. It's It's how much it's changing vertically to how much it's changing horizontally. Well, if you think about that, the vertical, we're talking here, the vertical, well, that's changing in which axis? The y-axis, right? So instead of vertical, let's say, we could say it's the change in the y values divided by the change in the horizontal, which the horizontal here is the x change. So it's the change in the x value. So that's another way we can think of the slope. It's the change in the y values over the change in the x values. And that just so happens to be where we're going to go next with this. We're going to talk about the slope formula. For just a moment here. Yeah, there is a formula that we can use when we have known points, x and y values of these 2 points. Here's the way it works. The slope of a line, tell you what, let me write it up here so we can really see it. Slope formula. The slope of a line with points and just like in graphing, you need 2 points for this slope formula, x1, y1 and x2, y2. Now let me just say a quick little word about that. Since I need 2 points and we're just doing the slope formula in general here, I don't have those coordinates, so all this means is I've got 2 points. This is my first point, this is my second point. Each point has an xy, so this is the first x, first y, second x, second y. That's all that means. There's no really any special thing about that. It's just a way of denoting 2 different points, 2 different x and y coordinates there. Okay? So anyway, if those are my 2 points, then the slope of the line with those points is given by this formula. Slope equals, and now here's another little bit of notation, m is going to be the letter designation for the slope. Why m? I think it has to do with the word slope in Latin or something like that. Don't know for sure, but somebody can take me on that. But m is the letter designation for the slope. Now, here's the formula. Remember we said the slope is the change in the y values, so that's y2 minus y1. That would give us the change in the y's. Then it's over the change in the x's, so it's x2 minus x1. Just means second y minus first y. Divide that by the second x minus the first x. And that gives us the same measurement as we were just talking about, the slope of the line. Okay? Rise over run. I don't know how some people just memorize it. It's the change in, it's the difference of the y's over difference of the x's. It's always the y's. Difference of the y's over difference of the x's. Y's are always on top. It needs to go that way to get the rise over run. Okay? All right, so let's compute here a couple of slopes using that slope formula. Okay. Find the slope of the line. With number 1, let's start with this one. How about 2, 3, and 6, 8. Find the slope of the line with those 2 points, 2, 3, and 6/8. Well, the slope, the m, equals, it's y2 minus y1 over x2 minus x1. All right, well, that just means, like I said, that's just the second y. What's the second y? 8 is the second y, minus the first y, which is 3. Divide that by the second x. Second x is 6, minus the first x, which is 2. So we wind up with 5 over 4. So this line has a slope of 5 over 4, positive 5 over 4. Okay? All right, number 2. Let's see. The trick of it all is keeping up with minus signs and all that. Let's say I've got, let's say 5, negative 3, and negative 4, comma, negative 7. Well, we get the slope there. Second y minus first y would be negative 7 minus negative 3. Now notice on that second part there, I've got minus negative 3. Why do I have two minuses there? Well, the minus here is from the formula, the minus. The minus 3 is because, well, you got minus 3. So you got the old double negative there. Now, for the x's, I got the second x, negative 4, minus the first x, which is 5. Now, what happens when I have double negatives like that? Turns into positive. Yeah. If you have two negatives right in a row like that, those turn to positives. Just the way it works. Then negative 7 plus 3 gives me negative 4. Now, on the bottom, I don't have the two negatives turn into a positive, do I? I just have negative 4 minus 5, which is negative 9. Which winds up being a positive 4 over 9. Again, these are fractions. If they reduce, you reduce them. Two negatives make a positive and all that. But now what I would, I'll do one more, then talk about it. But let me go ahead, while I have them up here, let me go ahead and notice here something about these. 2, 3, let's go ahead and plot these points. I don't know if they'll have you do this, but just to make a point. You got 2, 3, and then you got 6, 8. And then I've got 5, negative 3, and negative 4, 7. Somewhere like that. Remember we said the slope measures the slant and the steepness. Well, these both being positive, note there, both of those lines, if we're going left to right, they're headed uphill, aren't they? Turns out, anytime you have a positive slope, like these have, both of these are positive slopes, the lines are going to go uphill from left to right, just like these are. Now, that's similar between these two in that they go uphill. What's different about them? Talking left to right. Well, the one is steeper, isn't it? This one, if you were thinking about walking that hill compared to walking that hill, this one's much steeper. Well, do you notice here, this one's what? That's 1 1/4, whereas this one's 4/9, less than 1. So yeah, like I said, the steepness also is tells you a little bit. The slope tells you a little bit about that. This one's got a larger number than this one, so it's more steep. If it was a slope of 8, that's real steep. Slope of 10 is steeper. Slope of 100 is really, really steep. So the larger the number, the steeper it is. All right? So yeah, positive slopes go uphill. Let's try to get one here that has a negative slope and compare it. Is that okay? Any question there? All right. Number 3, find the slope. Let's do -2, 10, and -3, 4. Good one. What's your slope there? Well, you get y2 minus y1 over x2 minus x1. If you don't know that one, you might want to write it a couple of times. All right? So what does that give me? The second y is 4 minus the first y is 10 over the second x is -3 minus the first x is -2. What does that give me? That gives me -6 divided by, there's our 2 negatives in a row, so that's -3 plus 2. It's -1. What did I do? Did wrong again. Oh, shoot. That's a 6. All right, positive slope again. Not quite one. Let me try one more. How about, should have had these thought out a little more. All right, how about, I'll make it -3 and 4, and then 6, -2. I know that one's negative. Pretty sure. Okay. All right, so the slope there would be -2 minus 4, second y minus first y, over second x, 6 minus -3. Yeah, that's a -6 over 9, which also gives me a good chance there to say, well, we reduce that. What do we reduce it to be? Reduced by 3s, -2/3. Okay. It's another positive slope, and it's a 6, so that one's going to be, if I did it, I don't think I'll do it right here, right now, but it'd be a real steep line. This, though, gives me a negative slope, right? And so just to verify it does go downhill, let's look at the points here. -3 and 4. It's right there. 6 and -2. Voila. It's downhill, isn't it? That line, we always talk left to right. We talk about downhill and uphill. That one is running downhill. Negative slopes do go downhill. Okay? Questions or concerns?